Thank you so much, Harsh. We are ready for our next talk. And for this one, we'd like to go back to the overarching theme in tech right now, which is how do we actually use AI and integrate this with blockchains? And to talk all about that is Shashank, and we're going to talk about how to make smart contracts safer. So please give him a big round of applause.
Hello, everyone. I'm Shashank. I'm talking about scaling smart contract security with AI and automation, and this is something what we are building, and I hope you like the talk. So so I'll introduce myself. I've been in security for almost 14 years now, starting with web application security. I found bugs in Google, Facebook, Microsoft. Some of my finest work was 30 days in Apple iOS 10.3, which allowed me to remotely shut down anyone's iPhone, and I've been acknowledged for that. My Web3 journey started with Avalanche, where I was a security engineer. And that's where I realized there is a problem with the Web3 security, the world of smart contracts where so many hacks are happening. And how do we scale security? And that's where we started building SolidityScan. It is an AI-powered smart contract security scanner. And I'm not talking about the entire product. I'll just talk about one problem which we tried to solve with AI with a real example of a hack. So why is smart contract security automation? It is quite evident that it's like hacks have been a big problem in the Web3 world. Unlike the Web2 world, where the biggest compromise just leads into it's like maybe data leak or sometimes financial frauds. Here, it's always financial fraud, millions of dollars. If we see the numbers itself, last year it was 1.5 or 1.8 billion dollars. This year we are breaking records. We are already at $5 billion. So, and out of these, it's like $1 billion of hack, 55% of them are due to smart contract bugs, like the vulnerabilities in the smart contracts. And that's what we are trying to solve. So, it's like we have discussed about the problem, billions of dollars in hacks. And the way people resort to it is through manual audits, which is great. But that is not a scalable solution. It is required, but it is not a scalable solution. For example, you go for an audit right now, and then you make some changes. Then you have to resort back to audits again. What if one of your packages, for example, it's like OpenZeppelin package. If you're using that, it has a vulnerability. How do you get real-time insights about those 0 days? And that's where automation comes into place, which the Web2 industry has already done. It's like they have security tools in their CI/CD pipeline, which sits in their software development lifecycle, and then they it's like they keep on finding vulnerabilities. So this was the solution. It's like you automate smart contract vulnerabilities, right? It's like algorithmic patterns to figure out smart contract bugs. But then it has certain limitations which can be solved by AI. And this is what we did, and I wanted to show you one example. So for example, on 2nd September 2022, ShadowFi tokens were hacked, and that resulted into 316K in loss. And let's just try to reverse engineer the hack and how we can use AI and it's like automation to detect those vulnerabilities way before it's like it goes into production or mainnet, as you say. So let's see the transactions. So the hacker, what the first step he did was, it's like got some BNB. Of course, it was on BNB chain, so you need gas fees. So that makes it very clear. Second step, the hacker tried to buy some SDF tokens, which is the ShadowFi tokens. I think the first was a test transaction, and then the hacker bought like 9 ShadowFi tokens. Now, the interesting part is the fourth transaction. Anyone can guess what happened there. Like, by looking at the transaction, anyone can guess what happened there. Yeah, correct. So null address, almost 10 million ShadowFi tokens were sent to null address, which gives us an insight what the hacker was capable of. He or she, whatever, found a way to burn the tokens. It means they either had access to the burn function or something like that, whatever. So it is pretty evident the ShadowFi tokens were burnt. And now what's the result of that? The result is that the supply is less. So his or her token, 10 tokens, are more valuable, which was bought for like some cents, like 29 cents. But now it has more value. So if you see the next steps, 0.5, again, a test transaction maybe, and then swapped everything out, made $316,000. So this is one classic hack, a very simple hack, and we have multiple variations of these hacks in last year as well. And access control has been, number one reasons for smart contract hacks. So this is one simple example. So now we know, it's like we can verify from the code itself that, the burn token was public. So anyone can call the burn function and, it's like burn the token, deflate the supply, sell, make money, get out. Now, we decided, it's like 2 years back that, okay, let's automate these kinds of things. We managed to automate almost 300 or I think 400 different kind of vulnerabilities. But there was a limitation on top of that, especially with this main bug, access control. Now, access control can be implemented in various ways. For example, here the situation was they did import ownable module, but they never it's like called the modifier there, only owner modifier. Okay, so this is one way, but each developer has their own way of writing codes. Maybe they can have a require function, or maybe they can build their own RBACs. So how do you, it's like write all these edge cases? It's like if you go for an algorithmic coding, you have to write so many edge cases and you'll still end up missing vulnerabilities. So I'm going to show you a simple example. We scanned this on our platform, and we did find the bug. The bug was getting spotted, but the problem was this. Our automation program was saying there are 24 additional vulnerabilities as well, which is not valid, because they had some different kind of access control in place. And now writing an edge case for everything is a very difficult process. So what do we do? It's very simple that, it's like this is a problem of business logic which can vary from person to person, developer to developer. So what do? You use AI, because AI can understand context. So what we started doing was, initially what we did, we started, it's like feeding the smart contract function by function so that it can understand, it's like what kind of RBACs is in place, or what kind of, it's like access control is in place. And then let's see, it's like how, it's like how it performs. So when we did that, when we did that, you can see the cross mark with that robotic feature is basically the AI is saying that, okay, this is not valid. And then certain reasons have been mentioned that, okay, this is the reason why this doesn't seem to be a valid issue. And it correctly says that, okay, the burn function was a valid one. And this is the result of the matrix. Okay, sorry. This is the incorrect one, and it's saying that why it is incorrect is because there is already it's like a different kind of RBAC in place. And this is the matrix. So initially, when we were using it without AI, there was 24 detections, 1 valid detections, and 23 false positive. So this is huge amount of false positives, right? Like if you are, the whole idea of automating and scaling things is to reduce human work. And if you are giving, it's like 23 false positive, it increases the work of an auditor or maybe developer to validate, okay, this is false positive or not. But then with the AI, 19 false positives were reduced, which means an 82%, it's like reduction in false positive. So this was our first step. Unfortunately, I don't have slides after that because the recent deployment happened last week. So I'll just speak about it. So what was the next step? What do we do? It's like we have solved the problem of reducing false positives. But then even vulnerabilities can have, it's like different ranges, different variations, etc. So we came up with the multi-agent model, where what we do is there is a simple master-slave concept. So there is one AI which distributes the task to multiple AI agents. And we scraped it's like the audit reports of all companies, Solidate or audit contest and everything. I think we collected over 100,000 audit reports with it's like maybe 1 million bugs or something like that. And we started training our own AI model so that next time when we see a similar context in the code base, we can find vulnerabilities in it. So this is something we deployed last week, and it has been working very well for us. And that's what it's like this talk was about, that how we leverage AI so that you have kind of a it's like an AI-powered auditor sitting in your pipeline to reduce false positives to reduce vulnerabilities in your code, so that you are more ready when you go for a manual audit, or you go for a bug bounty program or something like that. That's my talk. It's very short because I tend to keep my talk short. I would be happy to take any questions if you have. Anyone? Yeah, please.
It just gets the contract and reviews it?
Use what, sorry?
Reviews it. Like
Oh, no, it doesn't review it. So I'll tell you the problem with AI. Right now, if you give the entire code base, for example, you have maybe even a mid-sized contract would be like 2,500 to 5,000 lines of code. Right now, if you give that completely to the AI, it won't work, because first, the problem is the context window cannot be that long. Second, it will start hallucinating. So consider how we are solving this problem is how you use ChatGPT. ChatGPT doesn't, tell you everything. You ask questions, and then based on that, it gives you response, and then you change your prompt to get answers. So what we did was, we already had, algorithms written for us for certain vulnerabilities. Now we guide that with AI. The multi-agent mode, it will have, certain prompts and RAGs set. And what it will do is, it will ask appropriate questions for validations, and then it will pass on into the backend, and then, we show the results. So it's a complementary mode with our own algorithms. Yeah. Thank you.
We'll just do one more question, and then we'll end.
Thanks for presentation. The question was regarding the security guarantees. Do you provide also formal verification? Are you able to define for certain pre and post condition that function works, or is there an invalid condition?
No, we are on the process of doing that. So actually, it was being very resource exhaustive, what you are saying, formal verification, or even fuzzing. So we have been doing that. This is again under experimental mode right now, where what we do is we give smart contract as a context, and then it tries to generate first test cases using AI. But yes, right now what we do is we read the code and we do static analysis of the code to find vulnerabilities. That would be something we'll be doing in the future. I guess that's it. Thank you, guys.